السلام عليكم ورحمة الله وبركاته. Welcome to Cairo Dar. We will continue the lesson 2 of transition elements, which started in the last lesson, in the last recording. Today we will continue the studying of physical properties of transition elements. Number 1 in the slide, atomic mass. We will study the atomic mass as the first property of transition elements. Atomic mass of these elements increase gradually by increasing the atomic number. A second property is the atomic volume. We notice that there is a gradual decreasing in the atomic size from scandium 21 till copper 29. But the decreasing the atomic size from scandium to copper is relatively constant. So the atomic volume of the first series of transition elements, we will find that this volume is relatively constant. Question: give reason. Atomic radius of the transition elements is relatively constant. There are two opposite factors affect this point. So the atomic radius of transition elements is relatively constant due to two opposite factors. Number one, when the atomic number increases, the number of positive charges increases. When the atomic number increases, the number of positive charges increases, and the attraction force also increases, while the radius decreases. Number two, when the atomic number increases, the number of negative charges, that means electrons, increases, and the repulsive force increases, and also the radius increases. Note that number 1a, transition elements have a small atomic size, and the variation in the atomic size is small. The variation of atomic size is small, so oxidation of these elements is difficult. So the oxidation of these elements is difficult. That means ionization potential increases. Give reason. One, on moving in the first transition state, in the first transition series from left to right, it becomes more difficult to oxidize the elements. On moving in the first transition series from left to right, it becomes more difficult to oxidize the elements. The answer: due to the slight decreasing in the radius, and the increasing in the nuclear attraction force to the valence electrons. Number B, due to the atomic radius is relatively constant, these elements are used in alloy industry. When the atomic radii are the same, the properties are similar, and this explains the similarity in the property in iron tried, iron coupled nickel. When we look to the third property of the transition element, which is the density, we know the density equal mass divided by volume. So in the transition elements, the mass increase and the volume is constant, is nearly constant. So we have a question here. Give reason. Number one, transition elements have high density. Number two, density of iron equal 7.87 gram per cubic centimeter is less than that of cobalt, 8.8 gram per cubic centimeter. The reasons of these two questions because density equal atomic mass divided by atomic volume, and the atomic mass of iron is less than that of cobalt, and the atomic volume of iron and cobalt is nearly equal. The fourth property of the transition elements of first series, boiling point and melting point. Melting point and boiling point are high because they have strong metallic bonds due to the increasing of valence electrons in the 3D sublevel and 4s sublevels. Number of free valence electrons affects the strength of the metallic bond, melting point, and boiling point. The number of free valence electrons affects strength of the metallic bond, melting point, and boiling point. NB. Copper and zinc are relatively soft and of lower boiling points, as their metallic bonds are weaker since they involve the participation of 4s electrons only. When we study the magnetic properties of the first series of transition elements, we will discuss the magnetic property, which is divided in two sections. Magnetic properties is divided to paramagnetic property and diamagnetic property. In case of paramagnetic property, the property appears in the substance in which the electrons are unpaired. Example, sublevel D contain electron, 9 electrons. A sublevel D contains 1 electron, 2B contains 9 electrons. In diamagnetic property, this property appears in the substance in which the electrons are paired. Example, D is empty or D is completely filled with 10 electrons. Maximum number of unpaired electrons equal 5. Maximum number of unpaired electrons equal 5, that as in manganese. Magnetic moment equal number of unpaired electrons in D sublevel. Transition elements classified into number 1, paramagnetic substances, number 2, diamagnetic substance. The transition elements are classified into two categories. Number 1, paramagnetic substance, number 2, diamagnetic substance. Paramagnetic substance is a substance which is attracted to the external magnetic field due to the presence of unpaired electrons in the D sublevel, which spin is in one direction, forming magnetic field. Number 2, diamagnetic substance is a substance which is repelled with the external magnetic field due to the presence of paired electrons. In the D sublevel, which spin in the opposite direction. Here we have a question. Compare between paramagnetic and diamagnetic. We explained that. Number 2, which of the following paramagnetic and which is diamagnetic of these ions? Zinc 2, copper 2, iron 2. We can solve this question, when we write the electronic configuration of zinc 2 and find the D sublevel is empty or completely filled. If it's empty or completely filled or have unpaired electrons, we classify this ion to paramagnetic substance or diamagnetic substance. In case of zinc 2, we will find that sublevel D contain 10 electrons and 4s sublevel is empty. So it's important to see that sublevel D, which is filled with 10 electrons, so this substance is diamagnetic. In case of copper 2, the electronic configuration of copper 2, we will find that 2 electrons of 4s are loosed, and sublevel 3d contain one electron, one electron unpaired, because this sublevel has 9 electrons. 8 are paired, and the 9th electron is alone in the 5th orbital of the 3d sublevel. This unpaired electron gives the copper 2 by a paramagnetic feature. And when we look to iron 2 and write the electronic configuration of iron 2, we will find that sublevel D has 4 unpaired electrons. Even that subshell 4s is missing his 2 electrons, but the presence of 4 electrons in the sublevel 3d of iron 2, these unpaired electrons give iron 2 the paramagnetic property. Transfer the other slide. You will see the electronic configuration of D sublevel of zinc 2, copper 2, iron 2. We will find in case of zinc 2, D level contains 10 electrons. They are all paired electrons. There is no unpaired electron, so the number of unpaired electrons equals 0, magnetic moment equals 0. This substance is diamagnetic. In case of copper 2, D sublevel contains 9 electrons. 8 of them are paired in their orbitals, and there is one still unpaired. So the number of unpaired electrons equal 1. Number of magnetic moment equal 1. This substance is paramagnetic. In case of iron 2, D sublevel contains 6 electrons. The first orbital contains paired electrons, and the other orbitals have 4 unpaired electrons. So the number of unpaired electrons are 4, and magnetic moment equal 4. So iron 2 is paramagnetic substance. Here, a question: give reason. Measuring the magnetic moment helps in determination of the electronic configuration. The answer: because when the magnetic moment equals 0, this means that all electrons are coupled. When it has certain value, this means the presence of number of unpaired electrons, and the magnetic moment is directly proportional to the number of unpaired electrons. So the magnetic moment is directly proportional to the number of unpaired electrons. Point number 2, ferric chloride is attracted to magnet more than titanium chloride. That is question: give reason why ferric chloride is attracted to magnet more than titanius chloride. The answer of this question depends on the number of unpaired electrons of ferric chloride or titanius chloride. So the answer: because of iron 3 has 5 ampered electrons. 5 ampered electrons. While titanium 3 has only 1 electron. Accordingly, magnetic moment of the iron 3 is more. Magnetic moment of iron 3 is more than titanium 3. So ferric chloride is attracted to the magnet more than titanium chloride. In the same type, ferric chloride is attracted to the magnet more than ferrous chloride. The ferric chloride is attracted to the magnet more than ferrous chloride. There is here a question. Arrange the following compounds in an ascending order according to their magnetic moment. Cupric sulfate, zinc carbonate, ferrous sulfate, ferric sulfate. To answer this question, we determine the ion of each compound. The first one is copper 2, the second compound is zinc 2, the third is iron 2, the fourth is iron 3. And we draw the electronic configuration of each cation of copper 2, zinc 2, iron 2, iron 3. And we can determine the power of magnetic of the we can compare between these ions according to number of ampered electrons of each one. The one of them which has more ampered electrons, which has magnetic moment, higher magnetic moment, and which has lower number of ampered electron has lower magnetic moment. Now we'll study the property of colored compound. Now we will see, or we will study the meaning of color, why we see the substance is colored. The color of substance results from the absorption of visible light. We see the substance is colored because from the absorption of visible light. The light is a form of energy. When the compounds containing transition elements, especially which have ampered electrons, compounds containing transition elements which have ampered electrons, are exposed to light, their electrons are excited by a certain color of white light. White light consists of 7 colors. White light consists of 7 colors. So the substance absorbs it and it doesn't absorb others. The colors not absorbed called complementary color. We see the color of the substance by the complementary color, which is not absorbed. So if the substance absorbs all colors of the visible light, it appears black. But if the substance doesn't absorb any colors of the visible light, it appears white or colorless. That takes place in the following cases. Case number A, in case of D has 0 electrons, D sublevel has 0 electrons, and D has 10 electrons. In this case, we will see the substance is colorless or white. Case number B, in case of ions or representative elements where they have ampered electrons in sublevel S and P, where the energy of the visible light cannot excite them to higher energy levels, so they are colorless. So in the representative elements S or P, the visible light cannot excite them to higher energy levels, so they are colorless substances. If a substance absorbs a part of light, colors, it appears in the complementary color. The complementary color is the net of colors which are not absorbed. Complementary color which are not absorbed. It's a net of colors which are not absorbed by the substance. It's color seen. It's the color seen. If the absorbed color orange, complementary color is blue. If the absorbed color yellow, the complementary color is purple. If the absorbed color is red, the complementary color which you will see greenish blue. If the absorbed color is green, the complementary color which you will see reddish purple. Give reason. Cobalt compound appears with blue color. The answer, because the energy required exciting the unpaired electrons in the 3D sublevel is equal to the energy of the orange color. So it appears with the complementary color, which the blue color. Note that number 1, compounds are colored in case of D has electrons from 1 to 9 electrons. Compounds are colorless in case of D has no electrons or D is complete with 10 electrons. Example number 1, scandium 3 colorless because the sublevel D is empty. D has no electrons. Number 2, copper 1 is colorless because the sublevel D is completed. D has 10 electrons. Number 3, copper 2 is colored because the sublevel D is not completed. D has 9 electrons. So this copper 2 is colored substance. The ion copper 2 is colored. Zinc 2 is colorless because the sublevel D completed with 10 electrons. So zinc 2 is colorless. Give reason. Copper 1 is colorless while copper 2 is blue. The answer, because electronic configuration of copper, which has 29 atomic number, is argon 18, 4s has 1 electron, 3d has 10 electrons. Copper 1, electron configuration of copper 1 is argon 18, 4s has no electrons, 3d has 10 electrons. This substance, this cation, this sublevel D is completed, so copper 1 is colorless. Copper 2, the electronic configuration of copper 2, argon 18, 4s has no electrons, 3d has 9 electrons. So the sublevel D is not completed, and then accordingly copper 2 is colored ion. Number 2, titanium 3 is reddish purple, while titanium 4 is colorless. We can answer this question like copper 1 and copper 2. Number 3, solution of cobalt are colored. Whereas solutions of zinc salts is colorless. The answer, solution of cobalt salts are colored because 3D level has 7 electrons. Sublevel is partially filled with electrons, and there is unpaired electrons, which cause the coloring of this ion, which means there is a number of unpaired electrons in the D sublevel, so it absorbs a color from the white light, and complementary color is seen. But solution of zinc salt are colorless are colorless because 3D contains 10 electrons, and this sublevel is completely filled with electrons, which means there is no unpaired electrons in the D sublevel, so it doesn't absorb any color. That means it's colorless. Note that there are some compounds, although the D sublevel is D has no electrons, or D contain 10 electrons, but they are colored, such as potassium permanganate is violet, although oxidation number of manganese in this compound equals 7. Now we'll study catalytic activity of the first series of transition elements. Number 1, elements of the first transition series are good catalysts. The elements of the first transition series are good catalysts. Number 2, finely divided nickel is used as catalyst for hydrogenation of vegetable oil. Number 3, iron is a good catalyst. Number 4, vanadium pentoxide is used as catalyst in the production of sulfuric acid. Number 5, chromium compounds are used as catalyst in the polymerization of ethylene. Number 6, chromium oxides or colloidal platinum on asbestos are used in many industries such as sulfuric acid production and ammonia production by Haber method. And due to the presence of the 3D and 4s electrons, which form bonds between the reacting molecules and the surface of the catalyst, which leads to number A, increasing the concentration of the reactants on the surface of the catalyst. Number B, rate of collision between the reacting molecules increases. Number C, the bonds in the molecules of the reactants become weak. Number D, the activation energy decreases and the speed of action increases. In the last slide, we give a question for what we explained later in the last slides. Write one use of each for each of the following: colloidal platinum on asbestos, chromium oxide. When we refer back to the last slide, we will find the use of chromium oxide or colloidal platinum on asbestos. Now, after finishing lesson 1 and finishing the studying of the properties of transition elements, we will finish this lesson, and in the next lesson we will study the iron as metal and the properties of iron. Then we will study the reactions of iron gathering. Thank you and goodbye.